Right now, humanity's fastest spacecraft is moving so fast, it could circle Earth in minutes. But even at that speed, it would take thousands of years just to reach the nearest star. That is the terrifying reality hidden behind every image of rockets, astronauts, and distant galaxies. The universe is not just big. It may be too big for human beings to ever truly escape. The fastest object humanity has ever created is the Parker Solar Probe. During its closest passes around the Sun, it reaches speeds of more than 430,000 miles per hour. At that velocity, you could travel from New York to Los Angeles in under 20 seconds. That sounds unstoppable. But space does not care about human intuition. Even moving that fast, the Parker Solar Probe would still need more than 6,000 years to reach Proxima Centauri, the closest star system to Earth. Not another galaxy, not the edge of the universe, just the nearest star. Think about that. Human civilization itself is only around 6,000 years old. If a spacecraft had launched toward Proxima Centauri at the exact moment the pyramids were being built in Egypt, it still would not be there yet. That is the scale humanity is fighting against, and it gets worse. Voyager 1, the farthest human-made object ever launched into space, has been traveling continuously since 1977. It has crossed billions of miles of empty space and officially entered interstellar space in 2012. But here is the part most people never hear. Voyager 1 has still not truly escaped the solar system. The Sun's gravitational influence stretches vastly farther than most people realize. Surrounding our entire planetary system is a gigantic shell of frozen debris called the Oort cloud. It extends potentially over a light year away from the Sun itself. Voyager has not even come close to leaving it. In fact, it may take another 30,000 years before Voyager finally escapes the Sun's outer gravitational boundary completely. 30,000 years. Recorded human history barely reaches 1/5 of that. And Voyager is one of the greatest engineering achievements in human history. This is the problem. Nobody fully understands when they imagine interstellar travel. Movies make the galaxy feel crowded. Ships jump between stars in hours. Entire civilizations casually move across the cosmos. Reality is different. Reality is emptiness. Almost everything in the universe is nothing. The distance between stars is so extreme that even light itself, the fastest thing physically possible, requires years to cross the gaps between nearby systems. Light travels at 186,000 miles every single second. In the time it takes you to blink, light could circle Earth multiple times. And yet even light needs over 4 years to reach Proxima Centauri. That means every star you see in the night sky is ancient history. Some of those stars no longer even exist. Their light is only arriving now. Human beings evolved for forests, rivers, storms, predators, and sunlight. Our brains are not designed to emotionally process cosmic scales. The numbers become too large for intuition to survive. So we simplify them. But once you stop simplifying, the universe becomes deeply unsettling. Imagine shrinking the entire solar system so that Earth was the size of a marble. At that scale, the nearest star would still be thousands of miles away. Not across a room, not across a city, across continents. That is the true isolation of humanity, and current technology barely scratches the surface of overcoming it. Every rocket humanity has ever launched works using the same basic principle. Throw mass backward to move forward. Chemical combustion creates expanding gas, and the rocket rides the explosion. It is powerful enough to escape Earth. But against interstellar distances, it is almost useless. There is a mathematical wall hidden inside rocket physics called the Tsiolkovsky rocket equation, and it creates one of the most brutal limitations in all of science. The faster you want to go, the more fuel you need. But the more fuel you add, the heavier the spacecraft becomes, which means you now need even more fuel to move the extra fuel. Then, even more fuel to move that fuel. The equation spirals out of control almost immediately. To push a normal spacecraft anywhere near even a fraction of light speed using chemical rockets, you would need impossible amounts of fuel. Not large amounts. Impossible amounts. In some cases, calculations exceed the total mass of planets, or stars, or entire galaxies. This is why humanity's fastest spacecraft still move like insects compared to the scale of the universe. And even if propulsion somehow improved dramatically, another terrifying problem appears. Time. A human lifetime is short. At current spacecraft speeds, a journey to even the nearest star would outlast dozens of civilizations. Entire languages would evolve and disappear before the crew ever arrived. Everyone on Earth would die. Then their children, then their grandchildren, then entire nations. The travelers would become disconnected from human history itself. This is why scientists began considering horrifying alternatives. Generation ships, massive vessels where multiple generations of humans would live and die during the journey itself. The original crew would never see the destination. Their great-grandchildren might, if nothing failed first. Imagine being born inside a ship, drifting through endless darkness, knowing you will die there, and knowing your children probably will too. Entire civilizations trapped in metal corridors between stars. And even those ships face terrifying risks. Microscopic dust particles become deadly at high velocity. A grain of sand striking a relativistic spacecraft could hit with the energy of an explosive weapon. Cosmic radiation slowly destroys human tissue. Isolation breaks psychology. One small system failure could kill everyone. The universe is not designed for fragile biological creatures. But then, physics revealed something strange, a loophole. In 1905, Albert Einstein published a theory that completely changed humanity's understanding of reality itself. Special relativity. And hidden inside relativity was a discovery so bizarre that it almost sounds fictional. Time itself slows down at extreme speed. Not metaphorically, literally. The faster you move through space, the slower you move through time, relative to everyone else. At normal human speeds, the effect is tiny, but near the speed of light, it becomes extreme. At 99% of the speed of light, time slows dramatically for the traveler. Years outside the ship pass, while only months pass inside. Push even closer to the speed of light, and the effect becomes almost unimaginable. A traveler could theoretically cross enormous portions of the galaxy while aging only decades. This changes everything. Suddenly, interstellar travel becomes physically possible within a human lifetime. But there is a catch, a devastating catch. Reaching those speeds requires absurd amounts of energy. The closer you approach light speed, the harder acceleration becomes, and the energy demands rise catastrophically. Near light speed, the required energy becomes almost incomprehensible. to accelerate even a relatively small spacecraft to relativistic velocity could require energy outputs rivaling entire civilizations. And then comes the second problem. You also need enough energy to slow back down. Otherwise, you simply fly past your destination forever. Humanity has imagined possible solutions: fusion drives, antimatter engines, laser sails pushed by giant beams of light, nuclear pulse propulsion using controlled atomic explosions behind spacecraft. Some concepts are theoretically possible. Some remain almost science fiction, but none currently exist at the scale required, not even close. And yet, strangely, the laws of physics themselves do not forbid humanity from reaching the stars. The universe allows it, barely. That may be the most unsettling part of all. The barrier is not an absolute impossibility. It is cost and energy, along with time and scale. The cosmos is not locked. It is simply unimaginably difficult. But even if humanity eventually masters relativistic travel, another horrifying realization appears. The universe itself is changing. Space is expanding. Galaxies are drifting apart faster and faster because of something called dark energy. Entire regions of the cosmos are slowly moving beyond reach forever. There are galaxies in the universe that humanity could never reach, even with near-perfect technology, because space itself expands too quickly between us and them. Every second, parts of the cosmos disappear permanently beyond the cosmic horizon. The observable universe is not fully reachable. Some destinations are already lost forever, and eventually, trillions of years from now, distant galaxies will vanish entirely from view. Future civilizations may look into the night sky and see only darkness, never realizing billions of galaxies once existed. The universe is slowly isolating everything from everything else, which raises a terrifying possibility. Maybe intelligent civilizations do exist. Maybe countless species rose across the cosmos. Maybe many of them looked up at the stars and dreamed exactly what humanity dreams now. And maybe they all discovered the same terrible truth. The universe is not built for connection. It is built for separation. Distance is not just an obstacle. It may be the final barrier every civilization eventually collides with. But despite all of this, humanity still builds rockets, still launches probes, still listens for signals in the dark. Because something inside our species refuses to stay trapped on one world. And maybe that instinct matters more than the odds themselves. Because every major step in human history once looked impossible. Crossing oceans, flying, walking on the moon, all absurd until suddenly they were real. Maybe interstellar travel will remain forever beyond us. Or maybe one day, millions of years from now, some distant descendant of humanity will stand beneath an alien sky and look back toward the tiny fading sun where all of this began. And maybe by then, Earth itself will already be gone. Thanks for watching. Don't forget to subscribe for more space mysteries.